Hello everyone, welcome to the third video lecture series on the basics of power electronics. So in the previous lecture series, we discussed about the importance of power electronics and the various devices, and we moved into different devices and its applications. So we discussed about diode and its applications, and next we moved to MOSFET and its applications. Also, thyristor, which is nothing but the SCR, and its applications were also discussed. So now let us move into the next the next device, which is nothing but the IGBT, or the insulated gate bipolar device. So here you can see IGBT, or the insulated gate bipolar device, is a three-terminal semiconductor device that combines the features of both MOSFET as well as BJT. So here in the simplified equivalent circuit, you can see that the IGBT, or the insulated gate bipolar device, consists of a BJT and a MOSFET, which is connected back to back, like how we saw in thyristor. Here, it offers a ease of control of this MOSFET with high current and low saturation voltage capabilities of MOSFET. So this IGBT, you can see, can be simplified and given as a single symbol like this. It can be given as a circuit symbol like this, where the gate is available, which is the gate of the MOSFET, and then you have a collector and an emitter, which is taken from the BJT, that is from that of an NPN transistor. So the voltage between gate and current is gate and emitter is given as VGE, and the voltage between collector and emitter is given as VCE, and the current flowing through the gate is given as IG. That is what is represented in the circuit symbol. So now coming to the operation of IGBT, the IGBT has three terminals: the gate, collector, and emitter, as mentioned. Similar to the MOSFET, a voltage applied to the gate terminal controls the current flow between the collector as well as the emitter. The IGBT combines the high input impedance of a MOSFET with the low on-state voltage drop of BJT, making it very efficient for high power applications. So this is generally a device which is capable of handling very higher power applications. Also, coming to the application of it, they are used in motor drives, uninterruptible power supplies, that is nothing but the UPS, the welding machines, and induction heating. IGBTs are commonly used in medium to high power applications where both high efficiency as well as fast switching speeds are required. Also, it is capable of handling high power applications. So now moving to the next device, which is nothing but the TRIAC. The name of TRIAC, or the expansion or the abbreviation of TRIAC, is triode for alternating current. So again, coming to the TRIAC, it is a three-terminal semiconductor device that acts as a switch, and it can conduct current in both directions when triggered. So this is the major advantage of the TRIAC, which permits the current flow in either directions. So hence it is used for bidirectional flow of current in high power applications. So now you can see the symbol here. It consists of a gate, a terminal T1 and a terminal T2, and the representation of it is given here. So the operation, coming to the operation, TRIAC has three terminals, MT1, MT2 and gate, or T1, T2 and gate. Applying a trigger pulse to this gate terminal, regardless of the polarity. There is no need to check with the polarity of this. Anywhere you can, with any polarity, you can trigger the TRIAC, and this causes the TRIAC to switch on and conduct the current between, as usual, between the terminal T1 and T2. The TRIAC remains on in the on state until the current falls below the holding current. So there is a current till above which the TRIAC is said to be in the on phase. And once the current falls below this on phase, then the triac is said to be in the off state. So the triacs are characterized by their holding current, gate trigger current, and the voltage blocking capability, which we are not going to discuss much detail here. And coming to its application, they are used in light dimmers, AC motor speed control, and AC power switching. They are commonly used in application where bidirectional AC current flow is required. And now coming to the last portion of this, which is the power converter classification. So here you can see that the power converters are generally classified into four types: AC to DC, DC to AC, DC to DC, and AC to DC. So AC to DC generally converts AC to DC efficiently, and this converts DC to AC, converts direct current to alternating current, which is nothing but an example of inverters, and DC to DC are the choppers, and AC to AC are the cycloconverters. So that's all for this lecture series. Let us meet up in the next video lecture series. Until then, thank you.